The Coco Nation show is an unscripted, live, and interactive broadcast. Anything can and will happen. The views and opinions expressed by members of the panel and the live audience are their own, and not necessarily those of the Coco Nation show, its sponsors, affiliates,
One. Okay, hi there. This is Mark again from the Coco Nation, and this is our second segment of our Tandy Retro Show. We've got 4 hours of jam-packed content for you. First 2 hours are going to go to Coco Digital Archiving. So I have a trio of 3 gentlemen to bring you information. We have L. Curtis Boyle. We have
Hello.
Excellent. We have Brian Wieseler, second on the list.
Hello, all.
Okay, I think that was good. Hopefully we can hear you all. And Paul Fiscarelli.
Howdy, everyone.
Okay, I think I have a volume level for everybody, so we are going to roll with that. And let me throw it over to Brian here. So Brian, you get the pin. So
I get the
Brian,
pin, huh?
Pin, full screen here. Come on, you full screen. Full screen there. There we go. And go to full screen on Zoom. There we go. Okay, and I guess we have a few people at top. So
Okay. Curtis can probably better explain some of this that we're doing here, but basically what we want to kind of cover is a purchase that I had made and the process that we went through recovering the data on it and what we recovered off of it and just the steps along the way that we used to recover that data. So that's kind of the basic layout of what we're going to be doing. We're going to start out first with a little show and tell. We'll show the drive and what we're talking about here, and then we'll kind of lead from there, and we'll go into some of the tools that were used. So first thing I'm going to do is I'll switch my camera here, and we'll do a little show and tell. Okay, whoops. And oops, is it coming across there? I guess I'm not seeing it right here, I guess. So
I'm not seeing it here.
there we go. There we go. Is it coming across now?
Yeah.
Okay. So what I was going to show here is, and for some of you that watch the Coco Nation show regularly, you will remember this drive, or at least seeing it. It's a big boy here. Let me see if I can't tilt it here just a little bit here. So you can kind of see the front of it. It's kind of hard to see here, but it's a big drive, big metal case. You got a couple of lights right here on the back side here. Got a nice big beefy cable, big 50-pin ribbon cable coming off the back here and a fan, and it's a big metal case. And then there was this controller here. So a little history with this. I came across this on eBay. And at first I saw just the case itself here and wasn't quite sure, but then scrolling through the pictures, I saw this, and of course this looks very familiar, to a lot of us, like either the J&M controllers and whatnot. This was a kind of a common case, metal case that was used. And so I looked at it a little bit closer and made an offer to the seller, and they accepted, and it arrived, and it's quite a beefy case here. It's made by a company. I don't know if I can show it here or not. Made by a company called Software Support, or yep, right there. If we can see it right there very well or not.
Software Support Incorporated.
Yep. And I can start out here first talking about this case a little bit here. I got the screws already off here. Is that coming through? Do you need me to zoom in just a little bit, maybe?
that would be better. Sure.
What's that? Oh, there we go. So you can see here it has the regular connectors here. I got the big 50-pin connector here. And then it does have its own ROM, but most of it's just some TTL circuitry that's going on here. Not a whole lot. Not a whole lot in here. The ROM's probably the main piece of it there. This is a 6821 that's here, and this is 2 TTL circuits with some resistor packs in here. That's about all that's inside this cartridge here. Okay. Is there anything else you want me to talk about on that one, Curtis?
No, the 6821, of course, is the PIA. There's a 6821 in the Cocos too. So.
Yep. The drive itself. Oh, back up the camera here. Oops. There we go. There we go. And Paul, I know you're a little more familiar with some of this hardware here, so feel free to chime in a little bit. There we go. So that big ribbon cable comes inside here, and they had quite a bit of shielding inside here. But here we go. So this would be classified as an MFM drive. Is that correct, Paul? Controller?
Sorry, I was on mute there. Yep, that's exactly what it is, an MFM drive.
Yep. And so this would be the interface itself that the controller would connect to, and then these ribbon cables here is what would connect to the drive itself, which is below this board here. Has its own built-in power supply, kind of a beefy one there.
And those two connectors, those two ribbon cables you're showing there, that's the same you would see like in an IBM XT drive, right? Like the Burke & Burke?
Yes. Yep. Just walking these connectors off here so you guys can get a picture of the drive itself. And some of you probably have seen some of those, seen some of these drives before. So there we go.
That's the actual controller board, and the Coco cart is basically just an adapter to talk to it.
Correct. Yep. Yep. And this is what would control the drive. And then below that is the drive, the physical drive itself. And these guys can get quite quite beefy themselves. Go ahead and lift this guy out of here. Oops, got one more connector here. I'm taking the time to show the drive because we're going to be using that here. Here we go. Okay, I'll slide this out of the way here so we can kind of take a closer look at the drive. The drive that was in this one here was a tandem drive, a TM502. And this happens to be, I think the 502 is the 10 meg version of the drive here.
That's a full height 5 1/4, right?
Yep, full height 5 1/4 drive. You can even see the stepper motor right here that would move the head itself. You can't quite see the platen motor. It's below all this, but big old beefy drive. It does come with like a faceplate. So if this was sticking out of like this might have been a similar drive that might even been like in the IBM, what was it, the 5100?
Yeah, PC.
Yep. So similar type of drive that would have been sitting there, and you would have seen the LED there.
Does that have a date of the drive? Like you usually have a sticker with bad sectors and stuff that tells the date of release, or?
So is this one have it or not? I don't see that this one does. But you're right though, Curtis. Sometimes they would have a sticker on there that would indicate any bad sectors and things that would have been on the drive. A little dusty. It's an older drive there. That's basically the drive itself. We'll be doing some more with it here in a second though. But do you guys have anything to share about the drive at all? These big drives.
I'm sure I've seen one in IBM PCXT before. The black
yeah.
face little LED. Yeah.
So okay. But that's the drive itself. So like I said, I wanted to kind of take it out there so you guys can kind of see, what this type of hardware would have been. But as Curtis said, like the Burke & Burke would have had something like this, but you would have, I don't know if he actually sold the drives himself. I think he did, as a part of his package. But this was sold by the software support company.
Yeah, and Software Support Inc. actually made hard drives for a lot of the micros back in the early to mid 80s. The regular tier Sadies, Apple IIs, Cocos.
Okay. That's all I got to show on this right here. I will show the cartridge before we move on to the next part here. Let me slide this over. I'm gonna switch cameras here real quick here. I'm gonna switch my camera over to the see here, there we have the mirror box. Okay. Just gonna slide this over so I can plug this in real quick here.
Okay, we're just seeing a black screen at the moment.
Yep. So let me go ahead and there we go. Okay. Let's see here. I can't see it very well. Let's see if I get my TV going here. Okay. So you can see here that that ROM that we talked about that was on the cartridge there, it actually it boots up with that where it says the software support. It says it's a 10 meg drive, hard disk operating system version 2.3, copyright 1985, and it says drive not ready. And we were talking a little bit about this, and what were you saying about this, Curtis? Here about that it's probably looking for like whether this was OS 9 or if the drive itself actually had like a boot partition on it.
Yeah, I haven't had a chance to look at the driver or the OS 9 driver for this particular drive here, but it does look like it was set up to have partitions of basically a 35 track single-sided drive, 630 sectors, kind of like, you know, RGB DOS and some other cantons and stuff used a little bit later. So it looks like it's basically the ROM and the way the drives are formatted and written to will handle either disk basic partitions and or OS 9 partitions as well.
Right. Okay. And so, and because this one's partitioned differently, it's not detecting that, so it just comes up and says, well, and of course the drive isn't plugged in or turned on right now, so it's obviously going to get an error.
Yeah, we'll find it there.
But even when the drive was assembled, when I first got it, this was the result that we were seeing here. So
yeah, and like I said, I haven't had a chance to assemble the ROM or the driver, but because this particular drive was OS 9 partitions only, I'm guessing that's probably why it can't find a directory track or anything
Right.
for disk basic. Now, just one quick little note here. You'll notice this is version 2.3, copyright 1985. That's because they started selling this drive in early 1984 for the Coco, and possibly earlier, which I'll go into a little bit later. A little bit of what little history I know about Software Support Inc. But they were one of the very first, if not the first, hard drive system for the Coco that I know of.
Right. Yep. Yeah, because I get where there's an ad here. We'll take a little momentary break here in a second here where I'm going to switch some stuff around, and Curtis has some ads that he can share with us that about this here. So I'll go ahead and turn this off here, and I'll switch my cameras again here. Give me 1 second. Just going to unplug a few things here real quick here. So unless you guys have anything else you want to share with this, I was going to go ahead and lead into the tool, the next tool that we used for this process here.
Okay. When did you want me to show the ads? Before or after?
In a little bit here, once I get to the point there where I'm ready to hook things up to the drive itself. But for right now, I'm just going to slide this out of the way here. There we go. Okay.
Your picture seems
We're still seeing the drive not ready screen from the Coco.
Yeah, it's got a tear.
Yeah, that would have probably froze there. So okay, let's see here. Get this positioned. Okay. Where's my video at here? Here we are. Okay. There we go. What I'm showing you here now is a board that was built by David. Is it? Help me here, Paul. Is it Greswine?
David Guesswine.
Guesswine. Thank you. Yep, wine. That E throws me there. Guesswine. So this is a board. It's a MFM emulator board, and let me flip it around here a little bit. If you can kind of see it through the grid work here, it's based off of a beagle bone. So basically, this board, this interface board here is a hat to the beagle bone, and I don't need this cable here. So the beagle bone has this connected to it. I have a network cable here, which we'll see here in a little bit. But what's kind of nice about this board here is it has the two interface cables right here. And these two cables here is what will connect to the drive here in a little bit. But the nice thing about it is that you can use this to back up an MFM drive by connecting the cables this way. And then through the utilities, if you want, you can do the reverse where you can take these cables and you can move them over to these edge card connectors and then plug this into this. So like this drive that I was showing here, I could take the physical drive out. I could mount this into that chassis, and this could emulate the drive itself once you've created an image off of a drive. So not going to go into a lot of detail right now with that, but the website, I don't know if it's going to come through here on this one, but it's we can put it maybe in the notes here, but it's www.pdp8online.com. pdp8online.com. That's the website that David has, and he has a whole bunch of PDP-8 related content out there. But if you scroll to the bottom of the page, you'll see a link to this emulator and the pages that support it. So at this point here, I was going to go ahead and get this hooked up to the drive, and we can kind of walk through that. Curtis, if you wanted to show, Mark, if you want to switch over to Curtis and spotlight him for a minute.
Brian, that's a nice little sled that you've got that mounted in. Where'd you get that?
Oh yeah, sorry. Thank you for saying that. Thank you. Yes,
I'm just kidding.
No. I was going to say that. I was thinking 2 steps ahead. So yes, thank you to Paul Fiscarelli. He printed this sled for me. It's really nice. And what's nice about it is that you can see it has the holes here, which would act as like the mounting holes, so you can actually mount this into into the 5 1/4 chassis, and the board itself mounts really nicely right on there. And it's nice too because it kind of elevates it. These boards, I don't know if you can see this or not, there's these whole row of capacitors here, and those capacitors are for is you can set a jumper on this board here for fill or drain. And if you have it on drain, when you plug in the power to power the board, if power is lost, the board just powers off immediately. If you have it on fill, what it will do is it'll charge up these capacitors. And so when there's a loss of power, the beagle bone will detect the loss of power, and these capacitors have enough power in them to give the beagle bone time to shut down safely. So you can power it either way, and they do hold quite a charge. I think it takes like 5 or 6 minutes for those to deplete, and for the beagle bone itself to power off. But yes, thank you, Paul. Yeah, I see he did a really nice job on this. It's smooth. It's
Yeah, I can't take credit for the design. The actual design was on David Guesswine's site, so the STL files there if anybody wants to download that and print themselves.
So, but Mark, if you want to switch over to Curtis for a minute. Let's see. There we go.
Okay, so doing some research on Software Support Inc. Now they were selling floppy drives and stuff too, which I'll show in a second here. By 1983, the latter part of it, they were advertising hard drive systems. Now they mentioned like the Apple II, and they said TRS-80 just by itself. So I don't know if that implied Coco, or if that was meant more for the Model 1, 2, 3, etc. Now, Mark Siegel in the chat here actually mentioned, he said in 83, he actually had the Coco version of this. So perhaps that original TRS-80 was actually for both. They just didn't really specify it. But this particular ad here, which specifically mentions the color computer, and for the first time they mentioned the color computer specifically, is from the April 1984 issue of Rainbow. But by this time, Rainbow was actually cover dated, I think, a month and a half to 2 months in advance. So this would have been in sale no later than February of 84. But from what Mark's saying there, it sounds like it was available a little bit earlier. So that previous ad, maybe they had the same problem I did where they weren't sure. You know, people were looking at the ad, is this for the TRS-80 Model 1s and 3s only, or is this also for the Coco? But as you can see, it was called Megadisc. And it was a big price breakthrough, as they say here, on hard drives. And this is for the TRS-80 color computer, TRS-80 Model 1, 3, IBM's, Apple, and the Franklin. 5 megabytes, including software drivers and 1 year warranty, power supply, adapter, the whole thing, only $1,000. So, dirt cheap compared to anything else. They even had a Canadian subsidiary. Micro RGS is what it was called originally, and then later on, it was actually sold to CRC. Now that's the same company that Tony DiStefano sold his disto stuff through, and I think his brother ran it, if I remember correctly. So I think Micro RGS might have just been a different name of it at that time. But yeah, they also they sold floppy drives and other things too here. They got a whole bunch of them here, and they were actually pretty good prices on those as well. So that was the April 1984 one, and then if I switch to a little bit later.
That's downtown.
So this is June of 1985, but they've upgraded the prices, et cetera, here too. Now you can get a 5 meg for only $500, but this is the one of the case design that matches what Brian has. Now, I don't know if they sold multiple cases and you just switch back and forth and they just happen to pick certain ones for certain ads. But the previous one was more of a different design than this particular one here. And you can see they're also selling color computer with J&M controllers and stuff for the Model 3, et cetera, too. And here, by this time, it was CRC Computers, which is the company that sold all the disto stuff in Quebec. And of course, they were still selling other prices. But here they upgraded too, because the original ones only were available for 5 and 10 meg in early 84. But now by mid 85, they're selling 20 meg systems as well. And the 20 meg system is $799, whereas the 5 meg system a year earlier was $999. So prices have dropped quite a bit by this point. And you can actually pick up a 5 meg one for $300 for an internal mount, or $500 if you want the power supply and case. So that showed you how fast drives are dropping. Now, this was still pretty expensive for a lot of us Coco people, and I think most of us waited until the Burke and Burke came out, which I think was late 87 or maybe early 88, where they were using off-the-shelf IBM PCXT drives, which, of course, then you got the advantages of bulk purchasing because there were so many IBM PCs out by that time. But this, as far as I know, this is the earliest hard drive system that the Coco ever had. There's some later ones like Canton brought out the SCSI interface stuff, and there's a few other, along this line, SASE style port stuff. But this is the first one I know that was actually bulk sold. And I think Steve Bjork had mentioned this is actually one he had as well when he was doing his development. And Mark Siegel's mentioned that was the one he had on his Coco as well. Have I delayed long enough for you to be ready, Brian?
Yes. Let's see here.
Proof that there's no autocorrect. There's an error in the city where CRC is.
Which is the spelling of the Laval or what?
Yeah, there's no E.
Oh, okay. That could have been one of the copy checking people at Rainbow.
Yeah, I remember CRC Computers. I used to go there.
I'm trying to remember the name of Tony's brother because I think he was the one who ran it. Shoot, can't remember his name now. Tony I met multiple times at Rainbow Fest. So.
Okay. Yep, I think I am ready here. Okay. I'll go ahead and share my screen here. Mark, if you want to switch back to me.
I think he already has.
Okay. Okay. Should be seeing a black screen here.
Yeah, we're seeing a terminal window, it looks like.
Yep. So I'm just using PuTTY here to telnet to the BeagleBone that's on the MFM emulator here, and you can see a little bit about what they're talking about here. You can see this is the BeagleBone, and you're presented with a basic login, and all of this is set up if you order it this way from him. Now I'm no expert at this here, so I may lean on Paul here to explain a little bit about what's going on here. And forgive me for those of you that are a little more Unix proficient. I just have some little cheat sheet here of some in Notepad of what I do when I go to read a drive. And but Paul can help me along here a little bit. Let's make sure we're on here then. So let's see here. I'm just gonna. These are just the steps I go through just to see if everything looks right. So what I'm going to do here is I'm going to go ahead and mount the SD card that's in the BeagleBone. It has a small little SD card in there, And when you create an image off of a drive, that's where you save it to. Or if you're using this emulator to actually emulate a drive, that's where you would read the disk image from. Okay, so you can see here that we got the drive mounted here. So what I'm going to do now is I'm going to step through here, and feel free, Paul, to step in and talk about anything that I'm doing here, so I'm not glossing over any of this here. I'm going to change to the drive here, the directory where he has all the utilities that David made for this here is in that directory there. So the next step that I would do here, and Paul, tell me if there's another one I should be doing before this, is to put it into read mode. This puts the BeagleBone into read mode. So you're running the setup here to say, okay, I want to read a drive. And that's what this command here does.
Yep, that's right, Brian.
Yep. And it comes back and tells you that. Now that, go ahead.
Got different design than
Sorry.
Okay. So the next one here, this is this command here does a read of the drive, but it does an analysis. So the -A is gonna do an analysis of the drive and kind of come back with some information. So you'll see it all kind of happen here. It's gonna have like spindle speed and some things like that. So you can see here that it's spinning at 3,500 or 3,594 RPMs.
Yeah, basically it's giving you the drive geometry.
Yeah, and back then most drives ran, or hard drives ran at a 3,600 RPM was what they're rated for, so that's close.
That's right.
Okay, so it talks about this command line, and this is one area where I get a little iffy as far as understanding though. But you can use this format, so when you get ready to read the drive, this will tell it what command line to use. But in the instructions that I followed, if I do the read command with a -A and then -T, it'll do it'll analyze the drive and it'll automatically use. You don't have to copy and paste this if I understand it right, the way that it works here.
That's right, Brian. Basically what happens is when it writes the file, it adds the metadata to the header of the file. So when it does the transition to MFM, you have the ability to just do the -T command.
Oops. So here's the next command I'm going to do here. So it's basically the same here. We're going to do a read, and we're going to do an analysis, and then the T is going to basically, I think it's like it's going to save it, and then I'm going to give it a path and a name of where I want to save it to. I'm just going to change this right now here. Let's see here. Instead of test, I'm just going to call it show, since we're on the show here, .raw. Now, do you do a raw or do you usually do a bin, Paul?
Either are is fine.
Okay.
It's all a matter of preference.
Okay. So you can see it's doing the same analysis that it did before. But once it's done here, then it's going to go through and you're going to start seeing a whole bunch of stuff fly up the screen as it goes and reads. And you're going to see a lot of successes. If there's failures, it's going to try to reread it a couple times to see if it can't get a good read off of it.
So basically what the device does is it allows you to do very similar to what a Grease Weasel does for floppies. So Grease Weasel will allow you to do a flux level transition copy of a floppy disk. The MF emulator here from David Guesswine does the same exact thing. What the -T command does is it takes that raw data, those flux transitions, and it does a transition or translation into MFM encoded file.
And this can take a little while. I think when I did this one, I can't remember. This might take 3 or 4 minutes here if I remember right. I can't remember.
It's almost done.
Yeah, 306 cylinders, I think you're supposed to get.
There we go. So is it saying here that it did some corrections here? Recovered after 14 retries. Is that saying that there were some that were failed, but after several retries it was able to get it?
Yeah, it mentions a little bit below that there's one bad data sector, and then 2 sectors corrected with ECC error correction. So it looks like it pretty well got the whole drive.
That's right. It's it looks pretty good.
Yep. So at this point here, so kind of circling back to what we were talking about in the beginning there about the whole discovery process. I was working with Paul in the beginning. Him and I were chatting about this, and because Paul also has one of these MFM emulators, and so him and I were chatting a little bit. He was kind of walking me through some of this, and we finally got the good read of the image here. And this might also be a good point too, that if any of you do have drives out there that you come across, and maybe you're trying to maybe you have a Burke and Burke and you go and want to buy a drive, if you know somebody, maybe take the opportunity to try to get that drive imaged first before you just go and blow it away. It may or may not be a Coco drive, but there might be something on there that you just not aware of. So if you have the opportunity to get this in front of somebody, to take the opportunity first versus just walking in and just starting to format it. At Coco,
Go ahead, Brian.
I was say at Coco Fest. I know AJ, and I'll be bringing my my MFM emulator here with me to Coco Fest. So not that I'm going to need it though, but it might be available. So if any of you are looking to do this, I'll bring my my box of hardware. If there is a drive that you have that you'd like to get an image off of it first before.
Yeah,
you
if
do
you guys
anything.
can recover my RLL hard drive that crashed on my TC9, where I've got some source code I never managed to get off.
Yeah.
Yeah, that'd be great. Does it have does this interface handle RLL format as well as MFM?
Yes.
Yeah.
Yep. So go ahead.
I was just going to say, Brian, what the way that I got involved in this was after watching the show, Brian doing this initial presentation, there were all sorts of suggestions coming in from chat and members of the panel about the drive's probably dead. You're not going to get anything off of it. Just get an MFM emulator, stick it in there, try to reformat it or whatever. And I just jumped on Discord DM and said, Brian, do not try to format that drive. I've got an MFM emulator. Let's try to see if we can recover this thing. And that's when he said he had his, and we started working together on this one.
Yeah, and it's been so cool. I tell you, when I have to be honest, when I saw this result that you guys are seeing on the screen, I don't remember what night it was. It might have been like 10 o'clock at night or something like that. And maybe this is true for a lot of you guys with the retro and stuff like that. When you see things like this happen, and I tell you, I got goosebumps, and so it was a lot of fun. So so I recovered this image. It's now on the SD card, and at this point here, I could actually shut things down. I could take the SD card and put it into my computer, and that's basically what I did. And then I, not knowing what to do with it from there, that's where I handed it off to Paul, and he started doing some of his magic to look at it. So is that a good segues there? Or is there anything more you guys want me to talk about with this? I know we kind of went kind of quickly over. We're not doing a deep dive into the simulator, but Paul, is there any other? Since I got the drive hooked up here, is there anything else that you know of command wise?
No, not that I can think of. You pretty well covered it. The only thing I was going to offer is, do we want to pause for questions at this point? If anybody on the panel had any questions or in chat, or do we want to just keep going?
Probably that's a good idea. Oh, by the way, Curtis, the RLL drives, the mechanisms are the same. Well, the bit density has to be correct because first drive I got tried to RLL, it ate itself up.
Yeah,
But
well, I know there's two different
physical
kinds of RLL too, because there's one that's half again as many sectors per track, and the other is half as many cylinders or something. I can't remember, because I remember I had to differentiate between the two to get the right RLL controller.
Gotcha. Yeah, so RLL is basically
Run length encoded.
Same. It's the same. It's the same MFM drive. It just encodes it differently, so it increases the density by 50% or whatever. So yeah, in the case of this, the mechanism is the same. It just has to be able to read the bit density and translate it. So, let's see.
Also, too, if you're wanting a little bit more information about this, if you go to David's site there again, the PDP8online.com website, when you get to the MFM portion of his website and you scroll down, you're going to see a link to a video, or you can just go to Adrian Black's YouTube channel. I think you have to go back a couple years, but he spends a whole hour talking about this, and I think he does touch on a lot of RL type drives as well. And you see him going through some of these same commands that we were typing here too. So if you want a little bit more information there,
Usagi Electric did a nice presentation too. He did tried to do a recovery on a bunch of MFM drives, and he also did another show segment with AJ from Forgotten Machines.
Yep, thank you.
And
yep,
the two of them together. And AJ, again, being at the fest, he has probably the most widespread recovery tools available in the retro world, as far as I've seen. He's got all different sorts of mechanisms to try to do disk and data recovery. So if you have anything, might want to touch base with him ahead of the show and see if he might be able to give it a shot to do the recovery.
And one of the lessons learned that I got from this whole process, which I will continue to do from now on, when I do get any hard drives, is I'm going to immediately hook it up to this MFM and see if I can't do an image. And the reason why I say that is that it's possible that that drive has one life to live. And if you, yep. And so you got one more power up. And so it might just be that one time that you power it up and hook up the simulator to it to try to get an image off of it might be the one and only chance that you get, especially if a read head or something like that takes a dive into a platter or something like that, and or the motor seizes up or something like that. So but like I am with the Coco, I know some guys are a little apprehensive. They want to check capacitors and everything. Me, I jump in with both feet and power it on when it's one that I haven't turned on for a while. And so I kind of did the same approach with a hard drive, but learning what I've learned here working with you guys, I'll take a little more caution with the drive now and take the opportunity to try to get it imaged the first time I power it on. So, but anyway, I'll go ahead and drop
comments.
Yeah, go ahead.
Comments, but I don't see any questions per se. So we can move on.
Okay. Well, from here then, if you want, Mark, if you want to go ahead and pass it over to Paul.
All right. Okay, Paul, we're going to pin you. Oops. That's allowed. That'll work. Okay, Paul, it's your show. And you're muted. And you're still muted, Paul.
Sorry about that, guys. Can you hear me now?
Yep.
We can hear you now.
Yeah, I lost my Zoom window when I hit the share button.
Yeah, it happens.
So yeah, I have no audio to share. But basically, yeah, what I ended up doing is after Brian sent over that file that he created, I started taking a look at it to see if we could figure out what might be on the drive. And the way that I look at it, I mean, it's pretty standard. I know other people in the community probably do similar things.
Could you make your window bigger?
I can.
Yeah, I'd say full screen on your shared area if possible. That way we can actually read it.
Is that better?
Yeah.
Yeah, I'm looking at my iPad here for the playback, so.
Does it look okay?
Yeah.
Yeah, it's readable. Yep.
All right,
It should
perfect.
be. Thanks.
So basically, when he sent over the file, I started taking a look at it. I took a look at it with hex editor. Another popular thing to do is just run this, use the strings command against it. And it's just this mtm502 file .bin. and we'll do type more. So I started taking a look at it, and any type of MFM encoded drive that's, you know, readable should, you know, start popping strings immediately. And as I started going through this, I started to see that there really wasn't much here. There's just a lot of garbage. So and there was a ton of it. So what I ended up doing was just typing that to TM502 text file. And what we can do is we can open that up in Vim. And again, not much there. So I pretty much manually went through the whole file looking for any type of strings that I could find. And as you can see, you know, it's several thousands of lines long. I'll share you guys the burden of having to go through it as I did, and go through to the line where I found a couple text strings. And I don't know if you guys can see that.
Yep.
There was
T. Harris and T. Earls, two of the programmers at Microware.
there's 3 files that I found, or 3 entries that I found that were readable text strings, and that was it on this entire drive. So my thought was, all right, there's a chance that there is some legitimate data on this drive, but the rest of it is corrupted. And I'm thinking more about it, trying to rack my brain as to what could be going on here. So, and for those that aren't familiar with the T. Earls and T. Harris, you probably recognize this screen here from the Three Musketeers from the Coco 3 ROM.
Yep.
So from there, my next step was to see if I could take a look at it with a hex editor and see if I was seeing any patterns there. Hang on one sec. And started scrolling through it, and I could see some patterns, but nothing that was really showing legit data. This looked like a unique pattern to me, and we'll go back to this in a second, but started scrolling through, I started seeing these repeats of these kind of entries here. We do a search. We can do a search all on those guys, and we find the 3 spots where they do show up on it. And yeah, that's all I could find as far as text strings on the drive. So another thing that I like to do with these files is see if I can see any patterns in them graphically. And there's a great utility for doing that called GIMP. It's an image editor. I use it quite extensively for doing a lot of Coco sprite work. And I use it with the sprite compiler and any of the other stuff that I do, graphics design work. One of the neat features of the utility, though, that a lot of people might not be familiar with, is you can look at raw data files with it to see if you can find patterns. And what you do is you just basically rename the file with the data extension on it. And when you do that, what it does is it brings up this little interface where you're loading raw data, and you can look at the data with various different encodings. You can look at it, you know, basically RGB, big endian, little endian, black and white, grayscale, that sort of thing. So for Coco stuff, typically what I ended up doing is black and white 1-bit. And as you can see, immediately it starts showing some patterns in here. What I'll do is I'll typically set the width to 256 bytes, because that's the width of a, standard Coco
Sector. Yeah.
2 graphic screen. And as you can imagine, a 10 meg file, that's how large this is, at 256 bytes wide, is an extremely long file. You can't load the whole thing in at once, at least not easily. But what we can do is we can start scrolling through the offset here and taking a look and scrolling through the file. And I've got some notes here. There's just thousands and thousands of lines of this image data that looks like just kind of like these random patterns here, but I've got some key spots marked down. Actually type in manually here. 697. Huh. There's a graphics image in there. That looks
That's from
familiar.
Interbank Incident. I recognize that. That's your player selection screen.
Yep. And we can scroll through some more. Oh, that's interesting. That looks like something from an adventure game. Ah, that's the beach scene from Interbank Incident.
Yeah, from the title
So
screen.
I started seeing data, but I also noticed that the graphics images didn't look quite right. And I know that they use the artifact colors, but there was something about them that just wasn't. That's one from the Interbank as well. And I remember she wasn't, her face wasn't black like that. It was white, and she had dark hair. So I'm like thinking to myself, I'm like, what the heck is going on with this? So once again, I went back to the hex editor and went back to these things that look like entries. And I started seeing these patterns here, and they look like OS9 directory entries, but obviously they look corrupted. Something's wrong with them. So as an example,
Those who don't know, directory entries under OS9 are 32 bytes per entry. So that'd be 2 lines of 16 bytes that you're showing here for each.
so here's King's Quest 3 OS9 disk, and it shows the directory entries. So doing a comparison between the two, I'm noticing, wait a sec, there's something happening here that seems like it's corrupt, but it's not corrupt. And I noticed the null values and the directory entries are zeros here, but on the disk image that we've got, they're FF. So I'm like, all right, it can't be that simple. Anybody on the panel have any guesses?
I already put it on chat. Not every bit.
So wrote a little Python script here to basically not every bit.
Lucy Blower. So, what do you get?
It doesn't like that, but I do have the corrected image here.
The demo gods struck again.
Yeah.
Looks like it was just the wrong file name. There was a addition to it that wasn't on the script.
And let me pull it up, the fix file.
Cool light cycle, by the way.
Well, thanks. All of a sudden, we've got the directory entries that are falling out. And I'll run the string command against that. Sorry for the delay here, guys. Full screen on this. And all of a sudden we're seeing data. And a lot of it.
Yeah.
And at this point, what we decided that we were going to do, copyright 1982 smoke signal broadcasting. What we decided to do is to see if we could create a virtual hard drive out of this. And basically what we needed to do that was remove the first 512 bytes from the file, put the VHD extension on it, and then boot up OS 9 or Nitrous 9. And we had this mounted through the emulator. And at that point, we got the big reveal. And I'm going to turn it over to Curtis at this point, unless other people have questions as far as what we found.
Well, I do have one question. Why do you think we had to invert the bits? Like, why was it inverted? Is that just the way certain controllers work, or?
So it's funny that you mentioned that, because I thought it was a bit odd as well. I reached out to David Gesswein to let him know that we found this weird behavior with this drive. And he said that it's not the first time that he's seen it. There were a couple other instances where he saw that it was the data was inverted on the drive. And he wasn't sure because of the number of third-party manufacturers back in the day. He wasn't sure if it was just kind of something that they did as kind of like their own standard. And one of the things that I'm not sure is where the inverting actually takes place. If it's taking place on the drive itself, through the drive electronics, or if it's through the power pack connector that goes into the Coco. But I alerted David to this, and basically what he did is updated his status page to now show that the TRS-80 color computer with the Megadisc by software support requires that you need to invert the data bytes on the drive. And there was a couple other manufacturers in here as well that he had cited. So that's how we knew immediately that, yeah, it was something that certain manufacturers back in the day was a practice.
So would that be the drive itself that's doing that, or would that be the controller that's interfacing to the drive?
That's what I asked. I don't know if it's the drive or the controller. It seems like it would probably be the controller. So the power, the interface card that goes into the Coco. I'm wondering if that's where it's happening.
If I may ask a question, on that list of machines that there with different controllers, can you look to see if there's the Atari Super hard drive interface on that list? Because the one thing that I was thinking is that, yeah, that's the ST, but I'm talking about the Atari 8-bit.
Nope.
Okay.
This is the only mention of an Atari.
Because if memory serves me, on the Atari with the Super hard drive interface, the data was inverted on that also, because it became an issue when you moved the drive from that to the Atari, to the ICD hard drive interface. And there is a commonality between the Supra and this one. They both use the 652022 for interfacing the SCSI/SASE hard drive. So it may be an artifact of using a 6520 for interfacing the SCSI device as opposed to a general SCSI chip or something.
Yeah, I'm not sure. He didn't really have a good explanation for it other than, you know, third-party manufacturers back in the day had freedom to kind of do what they wanted to do for their standards.
Yeah, the nice thing about standards, there's so many of them.
Yeah, exactly.
It makes sense it would be the controller, because otherwise it means this drive would have very special firmware that's different than other drives of similar type. But the controller, of course, is, you know, unique glue to hook the two together, so it's probably the controller, not the drive.
Yeah, I think that'd be a very interesting to look into to see if it's like you're using a PIA/VIA for interfacing to the SCSI bus as opposed to a chip or something.
Yeah. But the real important part is what Curtis is going to reveal now. It's what we found on the drive is the big part of this presentation here. So I'll go ahead and turn it over to Curtis.
Okay, so I'm going to share a screen here with a couple windows on it at once, so you can kind of go through the same fun I went through.
Here, Paul. Paul, do you need to unshare?
Oh, sorry about that.
There we go.
Okay, so I've got our Ledger's 9 EOU version of the technical reference manual here, specifically the random block file manager, RBF, which basically explains how hard drives and floppy drives and RAM drives and stuff are formatted. So unlike Disk Basic, which has its directory track on track 17 all the time, where the root directory will start on an OS9 disk varies depending on the size of the drive. But logical sector 0, and this is more similar to DOS type of thing, will tell you the schematics of the drive, basically, how many cylinders, etc., how many sectors. So that's what I actually looked at first. So here I've got the original version of the drive here. I'm going to do DD, which is a disk editor. And I'm going to open DD, which is what I've got it currently mounted as. But I've got the @ sign. So the @ sign means open it raw. And that means it's going to open the entire hard drive as one big honking file, basically. So if you match up the bytes here, like DD total, how many sectors on the disk is the first 3 bytes. So that's 009900 in hex, which works out to 39,168 sectors, which works out to 10,027,008 bytes, 10 meg drive, basically. You'll see the tail end of the word ectral here. That was the first clue, because there's only one company I know that did anything with the Coco that had that part of their name, and that was Spectral Associates. But then there were some oddities when I was going through, and there's other stuff you can go through here too, like there's the disk allocation bitmap, which tells you what bits or which sectors are actually being used and which aren't. Somebody had gone through the drive and tried to delete almost everything on it, and in some cases went a little bit above the beyond to actually wipe out some of the what do they call them here officially? File descriptor sectors, and this will become critical a little bit later on. But some of these have been modified and wiped out a bit too, or at least partly wiped. So this was the first one. It gave me a geometry. This matched, so this made sense. This is an OS9 disk. It's saying it's 10 meg. But then I found out there seems to be partitions, and you'll notice here, this is my notes on going through the drive, and it's a stream of consciousness as I was going through. And I've got a separate one for each image after I figured out there was multiple images, but there's a lot of crap in here. But basically, just to summarize it up here, I eventually figured out that this is actually divided into 3 partitions. So partition H0 goes from these sectors to these sectors, partition 1 from here to here, and partition 2 from here. And the reason I picked H0, H1, H2, as I go through the disk there, I found a directory that actually had all the separated modules from their OS9 boot. And they had H0, H1, H2 as hard drive descriptors. And those are all defined as roughly 3 1/3 meg. Now, there's a bit of a difference in the last one just because of the way it worked out, but I'm naming them basically the same as they called them. And if you actually jump to these sectors here, you can actually see the equivalent logical sector 0 of the partitions. So if I skip to 3623, now it's saying this partition is 3138 hex in size, and this one actually was named hard disk 1. And then if I jump over to this one here, no, I got dyslexic there. Now it's labeled hard disk 2, and it's a bit smaller. The way they set up the actual descriptors, the drives are like the geometry of the drive is a little bit weird, and they did reuse some of the descriptor for things that it's not normally designed for. So one of the things that a device descriptor, and you can use the D mode command that comes in EOU, for example, to see this in any drives you got, whether it's RAM drive, hard drive, floppy, or whatever, is that you have a HPA, which is a hardware address, is what it normally is. Like where's this disk controller mapped into memory in case you have multiple ones. And in this case, they were using it as an offset sector number to where the partition started. So H0 has basically a 0 offset, and H1 has the 3622. I think it's it's 3622 because it's 1 based. Logical sectors in OS9 natively are 0 based. So there's a bit of a change there. But basically, these descriptors had the hardware address reused for their own driver to point to where each partition does. So then we have these 3 partitions. The actual logical sector 0 on the physical drive treats the entire drive as one thing as far as this goes. The other 2 are basically the 3 1/3 meg restriction. They could have used some of this because, I mean, this sector is only defined for about the first half. I know Burke and Burke added some extra stuff here for alternate boot tracks if you hold down the Alt key and all this kind of stuff. But they didn't use any of this extra stuff probably because they didn't want to get microware's way in case microware decided to add to it. So they made it in the descriptor itself and the driver. So that's what figures out how to do the extra partitions. Now, I will mention one thing. As I started to go through to try to recover files here, I did not attempt to get the drive image to work the way it originally was supposed to before the deletions, because this has been a scratch drive of sorts. This drive has been overwritten many, many times over the years that they had it running. And there's chunks of files that are missing entirely. There's some sectors I found were rewritten to at least 3 times. And when you write, say, the final sector in a file, if you're only using, say, 30 bytes of the 256 bytes a sector is, it'll leave the last bytes alone from whatever was previously saved there. And then in some cases, I found like it's, the first 30 is this, and the next 40 is from a previous save, and the last one or last bytes after that is from a third save way, way back in time. And I was actually pulling out little snippets of that, which I'll get into some specifics on that a little bit later here. So basically, if you take a look at the logical sector 0, it actually has an offset to where to go to find the root directory, starting at 8. So 0015. So I'll just go to 15. And this will now have what is known as the file descriptor sector. Now, every file or directory will have this little header sector here. And basically, there's some attributes. This basically means it's a directory. The owner's user ID, which for most of the time for Coco stuff is just 0, though some people like us at work did have different user numbers. So you can actually have it, owned or created by a certain user number. Last date modified. Now, I did notice Spectral sometimes put a date and time in, sometimes they didn't. So some of them make sense, some don't. Link count, that's not usually used too much unless you really know what you're doing or you have certain utilities, but this means you can actually have the same file appear in different directories at the same time, but not take any extra space. So multiple places are pointing to the same file. Not really useful here. Size, that just tells you how big the directory entry or the file itself is going to be, the date created. And the segment list, this is the critical part. So the segment list always starts on the second line. And it's a batch of 5 bytes each time. So in this case here, you'll see you got 000016. That's the start sector number or cluster number that this directory entry is going to start on the disk. We're on sector 15 right now. So the header is literally 1 sector before the actual directory. And it's going to be 7 sectors long. And that's the segment list. And you can have up to, I don't know what did that number? It's about 48 segments I think you can have per file. And if you have anything trying to go past that, you get a bad segment error from OS9 itself. But we'll go to the next sector. So the first 2 entries in a normal directory, now some people override this with special utilities, is always ... and dot. And ... goes up a directory, and single dot is your current directory, same as Unix, same as DOS is. The last character of file name is always going to have the high bit set. So you'll see ... 2E hex is going to be a period. And then you add 80 to it to set the high bit. And now AE is the second dot. And that marks the end of the file, and everything else is zeros. And then the last 3 bytes of every 32 bytes, every 2 lines you're seeing on the screen here, points to where that actual file is. So in this case, the ... previous directory is pointing to itself, because we're on the root directory. You can't go any higher than that. And then the regular dot for the current directory is also pointing to 15. So the previous directory and the current directory is just going to point to the root directory because that's where we are. After that, we've got actual file names. So I've got like the commands directory here. You'll see that the final S has the high bit set, so it's a D3 instead of a 4. or 5.3. And then there's some other ones here too as you go through, and you can actually see the other files in the directory. And anything that's been deleted will have the first byte zeroed out. Disk basic does the exact same thing for deleting files. And it'll also update the disk allocation map, which they had cleared out most of the disk allocation map. Like this is it here. There was a couple directories that were actually on the drive to begin with, but most of it's been zeroed out, even though there actually is data on all of these sectors. So this is where I just started doing a lot of manual crap. So basically I went through and I started making all these notes and kind of tracking them. Now, some of these files, because they've been overwritten so many times, were pointing to something that you could tell instantly is not what it's actually pointing at. It could be like the middle of a file that they wrote later in some other directory. It could be that the file starts there, the start of it's there, but you go a couple sectors in, all of a sudden it's something completely different. So there's a lot of hand going through all this crap to figure out exactly what you're getting into. Now, I will mention that in this case here, because the Software Support Inc. drivers is basically set up to handle disk basic or to handle OS9, is that they've got a really weird drive geometry in the descriptors. Now, I already mentioned that the hardware address is actually pointing to the offset for the partition. That's pretty obvious once I figured it out. And then some of them make some sense, like 32 sectors per track. That's pretty standard for that time period drive. 1 sector per cluster. That's nice and easy. The actual size of the sectors per track, though, on the partitions is actually a bit strange. They have one head. The first 2 partitions are 20 tracks each, and the last partition is 19 tracks. Well, I thought, well, that's how big are these friggin' tracks, you know? And it turned out that there's 630 sectors per track once you get into the descriptors. And that basically means that that's the exact same size as a 35-track single-sided double density disk. That happens to be the exact size of a standard disk basic floppy, the entire floppy disk. So they've got the OS9 ones that you have to do these on even multiples of 630 sectors, which basically means they're leaving room that you just have to offset the track number, and that'll skip over that many disk basic partition. So if you had a mixture of, say you had like the first 4 were disk basic, and then the next one after that was OS9. Well, the first 4, you just skip that. So you set your track number to 4 to skip tracks 0, 1, 2, and 3. And then the OS9 partition starts there. So basically they have it so you can intermingle. And this is something that Canton did with the RGB DOS, and I think HDB DOS does. It's like a lot of the current ones that we use these days do the same thing. As far as I know, this is the first one that did that type of partitioning scheme. And just because of the way it divides out for the 10 meg drive, the last one is 1 track or 1 set of 630 sectors less than the rest of the drives here. So it's a little bit smaller. It's 3 1/8 or something like that. I can't remember the exact math on it, but just because it just didn't work out, you can't divide it dead even. So that was another interesting thing there. So I'm going to switch to, now, as I mentioned before, I wasn't going to try to reconstruct the entire disk allocation bitmap, which means if I tried to write normally, like just build a file or edit a file using a disk edit or a text editor or something here, I could conceivably scramble stuff here because a lot of the stuff is marked as unused. You can go ahead and overwrite it, but actually it has data I want to get to. So as I slowly recovered files, basically by changing these file descriptor pointers, and I'll just skip to one of those again. Let's take a look at the startup file, for example. So this the file descriptor here is pointing to the startup file being at 04F1, and it's 1 sector long. So if I skip to 4F1, you can see shell I equals T2. So they're creating a shell on a terminal on a RST32 port with an ampersand to run it in the background. That was their little startup file. So as soon as the Spectral booted this drive up, it would immediately fork off a shell onto the terminal they had plugged in, 888 column terminal plugged in. So then I have to go through, and as I fix pointers so that they're pointing and they get the right size of how big the file is supposed to be and stuff, I would immediately copy it off onto a brand new, fresh, blank hard drive image. And the point of that is that I don't have to spend a ton of time trying to fix the allocation tables and all that kind of stuff. I just recover the data and copy it off onto a legitimately formatted drive. So don't edit anything like this directly as far as building text files or redirecting output or something. I just used the hex editor just to change pointers. That's all I basically did all over the place. And now here's an example actually of stuff that has been written to multiple times. So the length of the file, so you can find that again. for startup. So 1F9 is the header. So skip to 1F9 again. And if you scroll back up, oops, I had it here already. So the file size in bytes is 9 for 4 sectors. You can have, files pretty big here, but if you go to 900000000E, that's the size of the file, which in hex converted to decimal, that's basically 14 bytes. And if we actually go to 4F1 where that file is, the first 14 bytes is shell I equals /T2 ampersand, which is the fork of the terminal. Now, whatever was left in that sector before they wrote the startup file is still sitting there. And you'll see it's a whole bunch of FCB statements. So it's source code for some assembly language program from a previous run through in this drive. And as I mentioned, you can sometimes see clean breaks, so you can see multiple. I think the worst I saw was 4 over top the same thing. So this drive was in use a lot, and they kept rewriting over it. So I'm assuming it was kind of their work drive, their scratch drive type thing. And sometimes you get lucky and like maybe you go to the next sector down, and maybe that FCB will continue over. Nope. Well, actually, in this case, it might have actually. And you can see labels and stuff, and then you'll suddenly see it change to binary data, or it might change to a different data in the middle of somewhere else. Here you can actually see this chunk of FCB statement stopped here, and then because it starts in the middle of a word, that means this is another previous run through had this other data here, which happened to have Spectral Associates' actual address at the time, which actually I think they did move once or twice. So now you're getting to different, code. And this is the part I had to kind of go through. If I could find the start of a file and it looked legit, I could just, patch up the file size and which sectors are being used, how many sectors long it is. But that takes a lot of time, and it was going through over and over and over again. And basically, I ended up going through all 3 partitions. I created separate VHD files where I copied the partition over there so I could just work with it isolated instead of the whole drive as a whole. And then I would copy stuff onto a new drive. So I'm going to switch over to the new drive where I copied all these files after I fixed them, just so you guys don't have to go through all the turmoil of doing this all by hand like I did. So let me just switch this.
So for the audience, are you getting an idea this kind of work is kind of tedious?
Well, it did take me quite a while. And like I said, this set of notes here is only for the first partition. The other ones are just as long, if not longer.
Hats off to you, sir.
And I'm not quite done because there's some parts I found where if it was broken into multiple segments, multiple multi-sector segments, I've gone through and amalgamated some of them together. If I find out, this one cut off here, and then 80 sectors later it picks up again, just because of the way fragmentation on disks works. But then I would, merge them in together to make them into the proper file again. But I only did that for a certain chunk of them. There's probably more of that to do as I get time. But this is all the stuff that I managed to recover. And there you'll see some, weird things like source fragments. I don't even know where these chunks come from. And a lot of these smaller ones are basically, leftovers on a single sector. I wanted to show one in particular. And this is the only parts I found, but Madness in the Minotaur, which originally was sold in 1981 by Spectral directly themselves, and then Tandy picked it up a little bit later. There's 2 tiny little chunks left over from that. And thanks to Paul pointing me, somebody had actually disassembled Madness in the Minotaur and actually created a web page describing it, is that actually I could link this up to where the original code was. So in this case here, I mentioned this corresponds to 1D59 in the manual disassembly at the http computerarchaeology.com/Minotaur code HTML. And the stuff on the left here is the actual FCB statements from Spectral's own source for building Madness Minotaur, and the stuff on the right is the equivalent these guys did when they redisassembled it. And these first comments like kill Satyr and kill Minotaur is actually Spectral's own stuff here. And they also have some offsets. Some of these card-coded values you see that the disassembly had, they actually had offsets based on certain variables they had set up and stuff too. So we actually have some of the labels and we have some of the stuff in there that you could actually kind of go back and figure it out. And I'll just show you the second fragment, which has a little bit more. Oop. Oh, that's spelling out. This one corresponded 79, so a completely different part of the disassembly. This actually has some actual code. And then these are the Spectral labels on the left. These are the disassembled ones on the right. And you'll even see some remarks here about different things here. Like they call it the lamp on status on the redisassembly. It was called lamp flag in the original Spectral. So it's kind of neat seeing what the original labels and stuff were. Unfortunately, there's not a heck of a lot of madness left on this disc because that was written way, way back, and they probably copied it onto this drive when they first got it. And then, eventually sold it to Tandy, didn't need to worry about reassembling anymore, then deleted it and started just overwriting it with everything else. But there's a bit of here from Madness the Minotaur. There's also some bits from Ghost Gobbler, I think. And some of these I can't even tell, they're so small chunks that I can't tell what's in there. Yep. There's a nice, really small one. I quit gooing those after a while because that was just being too tedious. Secondary direction, no. Trying to find, there's one that's specific. Yeah, here we are. Check to see if the ghosts hit the center. And get Eater, which is what they call the Gobbler itself, the Pac-Man. A horizontal coordinate, 4 offsets and stuff. So basically, this is part of controlling the ghost traveling around. And the Eat location here, the absolute screen position of the Eater. So you can kind of pick up some other labels and stuff. I've got there's a bit more chunks of Ghost Gobbler, and there's probably like 15 or 16 little single screen or less type things. Not enough to disassemble the game, but at least enough that you have some of the original labels and you might be able to figure out what some of it does without having to like go through the code and figure it out yourself. So that was kind of fun finding out those kind of things. They're like hidden little gems. There's not even close to a complete source for these really, really old games because, I mean, Ghost Gobbler came out in mid-'82. Madness came out in late '81. So we're talking way, way back in the Spectral catalog. Now there's a whole bunch of stuff. There's way too much for me to cover on here. There's some third-party stuff that they have where they'd bought in utilities and stuff from other OS9 stuff like the Smoke Signal Chieftain, Smoke Signal Broadcasting, I should say, that Paul showed off earlier. That's actually an OS9 and Flex hardware manufacturer actually that did some of their own software as well. Suspect out some of their utilities. They even have some utilities where they got the source code from the original authors and were modifying it for their own purposes. Some of that's complete, some of it's not. I'm going to be going through some of that. Like there's still a lot more work to do on this, but we can show you some pretty cool critical things. So the first one I wanted to kind of cover here, I'm sure many of you are familiar with the Unraveled series by Spectral, the books. And you can see we've got some pretty large chunks in certain parts here. But we've got some of the original disassembly code, the stuff that you would build and assemble, and then we've also got some of the output listings, which is what they use in the books. Those have like line numbers and other things like that added, what byte codes are going in. But there's actually a few little bits in here that are not in the original books, which I found kind of interesting. So, so if you go through the super extended Unraveled book here, I don't remember exactly which line numbers here off the top of my head, but some of these lines are actually not in the actual printed version of the book or the PDF version of the book. These are ones that they considered not really all that overly useful. And you can actually see if you go through the listings in Unraveled, they have the line number on the left column, and you'll actually see it like skip 60 lines. And these actually, some of these are actually in here. So if you wanted to see the original full listing, including some stuff they kind of deemed they didn't need it in that part of the book, you can actually get them back. So it's like going through some of the different re-entry points for color basic and extended basic and enhanced basic for the Coco 3. And there's, some pretty big listings in here too that are actually part of that as well. Let's see what's the big ones here. Oh, also they have these little script files. So here's the one to actually assemble extended and color basic 2.0. And you'll see it's using an H serial, and there's a little DIS directory which no longer exists with a little temp file. And then it actually uses the assembler, and they modified the original level 1 assembler themselves with a few changes. Basic 2.0 output to this directory that no longer exists with 25K. And then they had an optional line they use sometimes here to do a compare to make sure it actually assembled to match the original ROM dump. And they redirected all this to term 2. Term 2 was their 80-column terminal. So they were doing these assembly listings on the Coco itself, but they were redirecting it to an 80-column terminal rather than the 32-column screen that the original Coco 1 and 2 had, because some of this stuff is Coco 1 and 2 before the Coco 3 came out. And boy, do we got some stories to tell you about that a little bit later. So that was really cool. So there's a fair bit of level 1 stuff. There's part of the source for stuff like Pan, which is the music player, Interbank Incident. You already saw some of the graphics that Paul had found. Cave Walker, there's some of those as well. But one of the things that I think, Paul, you had found this first too, to looking at some of the text strings, is that the Coco 3 demo, the one that Tandy put on in the stores for the Coco 3 itself, is one of them in here. And we've got a good chunk of the source in here. I don't know yet if it's complete. But there's quite a bit in here. There's some of the little batch files, there's some of the listings, there's some of the actual raw assembly source files for it. And there also seems to be a bit of a slightly older version of it on here, because if you compare the text, like if you remember on the demo, there's that one part of the screen that has the crane, and it's like picks up a Coco and lowers it down and says Color Computer 3, and then picks up a multi-pack, drops it down, and says multi-pack. And there's a few cards that it plugs in the multi-pack, and some of the text on the demo, as you would see it running at Radio Shack, or if you download from the archive, is not exactly the same. Like there's some switching between a sound speech pack and an RS-232 pack and stuff. So there was an earlier version of the demo. I did talk to Mark Siegel about this via Facebook Messenger recently, and he was mentioning that he did not do any of those changes. He think it might have been marketing that was doing that. So he thinks Barry Thompson or somebody like that might have actually been the one that's requested some of these changes. And Mark has also mentioned that Spectral had a rather unique relationship with Tandy Radio Shack, in that they weren't usually commissioned to do anything by Tandy, like Greg Zumwalt and Steve York and others were, but that they would just make stuff up and then just send it off to Tandy and say, hey, what do you think of this? And there was like the Coco 3 demo, they had no idea Spectral was writing that at the time.
Yeah, also, Curtis, the credits on the first page, the author credits for the demo.
Yeah, because there's an
had
extra
all
name in
three.
there compared to the actual released one.
Yeah, Figgy, Gabbard, and who's the third one there? Can't think of it off the top of my head. But I had all three of them mentioned in that other version.
So like here's very common routines. Now this is now we should mention that the Coco 3 demo was starting to be programmed in March of 1986. That's what it actually says in their own remarks. Now, for those of you who know the history of the Coco 3, it was announced at the end of July of 1986 and didn't actually come out to the public until around September, October. So they had one of the earlier pre-production models of the Coco 3 at least as early as March of 1986 to even start working on this. Now, those of you who followed Roger Taylor and his basically stripping the masking off the gimme chip, you may recall this little thing here. So you can see this line here: load A at IRQ and enable interrupt. Get Tequila's interrupt status. Tequila was the code name for the gimme before it actually got called the gimme, or the, what is it, ACVC, I think was in the technical manuals. So this is actually them knowing the code word for the gimme chip before the public even knew the Coco 3 existed. So that proves that this is quite early on, because by the time anything got released.
And that's also confirmed in Roger Taylor when he did the uncapping work on the gimmies. You can zoom in and you can actually see the tequila etched into the to the substrate.
Yeah, and that's on the first version of the gimme. I think the second gimme had a different code name, if I remember.
Yeah, I forget what it was.
Now, one other thing I'll mention about the Coco 3 demo here that's kind of interesting, besides the main comments, they've got separate little assembly language files for each of the different subroutines. You can see the hills, that's when the little rainbow and the little music plays. The dungeon, where the wizard shoots the dragon. The planets demo that shows, sine, cosine, all kind of stuff. So we've actually got source for a good chunk of this, as well as the little edit scripts and stuff like that. And then they have these common stuff, and they have different levels of common. They have super common, which what do they call it? Very common, I think, is the stuff that keeps mapped into the main MMU blocks all the time. And they have some stuff that they remap in as needed, and then there's stuff they load off disk as needed. So they kind of really pre-planned this pretty good. There's some interrupt-driven code. They also compress the graphics because, of course, in the Coco 3, the screens are 32K long, so they wrote some run length and compression, run length encoded RLE, so that's the decompression routine they're showing there. Some of the shape tables for drawings and stuff. There's stuff about the ball, like I'll show the ball one here. It's also yeah, drawing the ball on the screen. This comment was kind of cute. Move the ball on the screen. Actually, we move the screen all over hell and back and leave the ball where it's at. Well, they definitely had a bit of a sense of humor. And we'll see a bit more of that a little bit later on, too. Now, there is references in the code here for the sound speech pack. And apparently Control-T will toggle it on and off on certain screens. Now, when I've ran the demo, I've never had my speech pack plugged in at the same time. So I don't know if it's auto senses here, but I've never seen a prompt for that. And there's a prompt where it actually says, do you want to enable the speech sound pack things? So if anybody has a multi-pack, downloads a demo and has that plugged in at the same time in whatever the standard slot that Tandy wanted was, I think it was 1 or 2, I can't remember. I wouldn't mind if somebody could try that out and see, does this actually use a sound speech pack? I would guess it probably just uses the speech part, because I don't see anything in the code that resembles playing music through the sound speech pack. But I do see a few references to misspelled words, which kind of tells me it's probably doing the, what is it called, the phonomics or whatever the heck it is, for how speech works in the speech pack, where you have to spell it phonetically. So I'm guessing that's kind of where that's coming from. Let's see. And here's the main comments for the beginning of the program itself, which I'll read for the audio listeners. A demo program showing off the spectacular features of the new Color Computer 3. This program is being written in OS 9 for use on Color Basic. In order to load into BASIC using the loadm command, a preamble and postamble are included in the listing. After transferring the binary file to TRS-DOS, the program will load and execute. Started March 1986, this is months before the Coco 3 even got announced, written by David Figge, Tom Rosenbaum. Now, Tom is not on the final credits if you run the demo. And Tom is the person that created and was the first programmer for Spectral Associates. So it looks like he was directly involved at the very beginning, and then he kind of did hands off when he was busy running the company. And John Gabbard with graphics by Gene Gatlin. So he actually got his full name because he's just listed as E.T. Gatlin in all of the credits that he's on, including Interbank Incident and the demos, etc. And it's just copyright 1986 by Spectral Associates. Now, one thing I found out from Mark is apparently Spectral Associates for Tom Rosenbaum was just a side gig. He was actually a bee farmer for making honey and stuff, and that was his main thing. And Mark says he still has a jar of the honey that Tom gave him from his beehive farm thing. So that was something I had no idea.
It'll never go bad either.
No, that's what Mark said too.
One thing, Curtis, as you were just mentioning in the notes, it reminded me, you and I were talking about this. It seemed at this point, Spectral was using OS 9 exclusively as their development platform, even for just extended color basic targets. And I thought,
yeah, as of about 85, 84, they were doing that.
Yeah, I thought that was pretty neat.
Yeah, I think once you got the hard drive, like most of the disk basic stuff, like the hard drive support by software supporting only supported floppy sized things. So if you wanted to output a listing and have your source code, you probably couldn't fit it in 153K. So in this case here, you just go to OS 9. And I mean, Dragon people did this too. We've played a few of the Dragon machine language games that were like Rommel's Revenge, for example. Those are all written under OS 9 as well. And there's multiple other ones too. So it's just an easier development environment. The assembler had more access to RAM, especially in level 2. So you could do a lot more with it. It took a lot less room than EdTASM. It was generally faster if you're running on a hard drive. So it just made things a heck of a lot. Plus you could output to an 80-column terminal, which you'd have to write whole routines to do that in disk basic. So they got their 80-column screens for free.
Hey, Curtis, there's one comment here from Nightwing. It says, rather gen assembly on a Smoky than fight using a Coco. And I believe Smoke Signal Associates was somewhere referenced somewhere in there.
Yeah, Smoke Signal actually produced 6800 and 6809 based systems, selling in them with both Flex and OS 9.
So plus it's possible maybe this was a Smoke Signal system that they were using for OS 9. Also, Exile said the 87 Gimme was codenamed Tortilla.
Codename what?
Tortilla.
Tortilla, right. Yeah.
Yeah.
I do remember they started with a T, but.
Nightwing also says both Robot Oddity, I think it's Odyssey, and Carmen San Diego used OS 9.
Yeah. Carmen San Diego was done by Broder Bundle. So that's a different.
Yeah.
Then the Christmas demo, we've got less there, but I got a pretty big chunk of the listing. It's not complete, but. And this one also was started according to this. Well, this might have been stolen. I think they took the original Coco 3 demo, copied the code because a lot of it was common, and then they wrote the Christmas demo basically using a lot of the same basic Coco 3 graphics engine, etc. But here's like, for an example, they're describing in the DCOM 2 routine, memories and routines for the Christmas demo. But here they're describing screens 3 through 5. So they kind of plan these scenes out. So this screen will show a wintry scene with the Radio Shack truck on the road. It will start with simply a picture of a road. The truck will enter the scene from the left side after the truck has traveled between a third and half the screen. The scene behind the truck will start scrolling by. After traveling a distance, a dog will appear and run in front of the truck. The truck will stop, a man will appear and catch his dog. The two of them will walk off the screen and the truck will continue on. The truck will drive up to a Radio Shack store and stop. The scene will scroll past via the horizontal virtual enable. There will be two screens, each 49,152 bytes large. The truck will travel in a 35 pixel high strip towards the center of the screen. And it kind of goes into more technical detail. So they're kind of planning the scene, and they're also planning exactly how they're going to do it, all in the remarks there. And you guys probably remember that scene because it goes driving and, the tires are bouncing and it gets to the Radio Shack store, and then it switches to show Santa taking, Coco into the store type thing. So yeah, it's pretty interesting going through all this type of stuff. The next one, I'm going to show a bit of source, and then I'm going to let Paul, if you've got the proposal disk image handy.
Yep, I'm all set.
I'll just show a little bit of the source first. So this is the first of unreleased, previously unseen stuff that Speckle had going, but never finished and never released. So I'll read this one out as well. So it says Space Adventure Proposal, a program, and this is one where they're getting a little cocky, I might say. A program to blow the socks off Tandy, which will then approve the real thing. This program is being written in OS 9, same thing they said in the demo. Started July of 1986, so this is right around the time the Coco 3 announcement was happening, written by David Figge and John Gabbard with graphics by Gene Gatlin, so just the three. Tom's not in this one. And it's a bit of an animation thing. It's not a game per se. It's more like a graphics demo. It was one of the very first Coco 3 stuff. You can also see that some of this files have been updated different dates here. Like this one here is August 4th, 86 was last updated for this particular chunk. And you can go through, etc. So I'm going to stop sharing just for a bit here and let Paul actually demo, because he's the one who actually got this demo running because he found the working binary.
So I don't think I had to modify anything on here. I think it was just working out of the gate. It just extracted the binary and copied it over a floppy disk image. So yeah, here is the wonderful demo that's going to blow the socks off of Tandy. Just going to launch it in VCC. Can you guys see that?
Yes, it's coming through. Yep.
My socks are blown.
And then it just basically blows up from there. And that's it.
Wow.
So I took a quick look at the source code for this, and it looks like it starts off with some sound routine info. And I'm not sure if they were planning to have sound in it, but I never got sound to work in it. So anyways, that was the demo that was going to blow the socks off of Tandy. I think it was probably an inside joke amongst the Spectral guys.
Yeah, they might have just been learning how to use a 16 color mode and getting animations and stuff working, writing the new library for this, the new Coco 3 graphics modes is my guess. But Mark never heard of this, never saw it.
We got a good chuckle out of it though.
Yeah. Next up, let me share again here. Now, most OSINT development systems will have the defs directory, which is definitions, like basically labels for, system API calls and different settings and stuff. Now, this actually has a couple of interesting bits to it. So I'll view systype first, and this kind of defines what system you're writing for. So you might have a smoke signal, you might have a gimmicks, you might have a Coco. This particular one, and Spectral was apparently aware of this, is the color computer model type. You've got the original standard color computer and the deluxe. Now, this is pre-Coco 3, so this would have been back in the PAN, interbank incident days. But obviously, they got copies of the OS9 defs from Microware that actually, when the deluxe was still going to be a thing. So there's a mention of that there. And if you go on OS9 defs itself, and I have passed this on to Boise, they've got their edition history. Now, if you've seen the OS9 defs on the GitHub repository for Nitrous 9, or the ones that come in the OS9 level 2 defs, they'll have some of the earlier stuff and they'll have some of the very later stuff here, but there's a chunk in the middle here that Boise didn't get in the copies he got from Microware directly. They aren't in any of the other ones I've ever seen. And it seems to be right around the deluxe time. So you'll see like a comment here, March 7th, 1984, Mark Hawkins goes and adds the SS cursor and SS screen size for the Coco. Add a new signal code S window for Coco Future. Now that might even be alluding to the Coco 3, because that's usually where it's used. I don't know of any use of it in the Coco 1 and 2, though maybe they had some plans. But April 11th, 1984, added SS sound for Coco. Now, Boise did manage to get some of the driver stuff that Microware was working on for the Deluxe. SS sound was specifically to use the sound chip, the AY chip. So that was actually right around the time period the Deluxe was being developed. And then they have another one done in June, which is for the gimmicks. And then you'll see by March of 85, so literally 11 months later, changed SS sound to SS key sense because the Deluxe got canceled and there was not going to be a sound chip in the Coco 3. So they changed it to a key sense, which is to read the keyboard for certain specific keys faster than a regular, going through the entire PIA table thing to map it. This is just arrow keys, enter, break, and a couple other special ones, which they figured people use in games and would save you some CPU time. So by that time, they'd already canceled. And then they added some stuff for virtual IRQs, and they had stuff for communicating with modems and hanging up modems and stuff like that. But some of these comments had gone missing completely. And now we've got that little bit of history back. So like I said, Boise has already said he's going to be updating the repository to add these comments since we have a more complete history of how things got developed.
Curtis?
Yep.
Can you go back to that previous screen or sorry?
This one? Or
yeah, the one you were just reading from.
Okay.
The second to the last comment there. Does that say DTMFM device type or something? Is that what that says?
Yeah, that's the network file manager device type.
Okay.
I don't think that was ever on the Coco. Maybe they were planning with those few Ethernet cards, I think, that Mark Marlette currently has. But there was some of these for other OS9 systems like gimmicks, etc. So I'm guessing it was more for that, but we could have gotten it if those cards had ever come out.
Right.
Now, what I won't bother showing you, we've got most of the source for Home Publisher, it looks like. I haven't gone through to see if it's complete. And there are some changes to Home Publisher I do plan on doing now that I have source, because it's going to save me a hell of a lot of time disassembling it. But one thing that they have in there is that when you bought Home Publisher, it came with a bunch of printer drivers. And these are all dated from 87 when Home Publisher was actually made. There's a whole batch of other printer drivers added in late 88, early 89 that, as far as I know, never got released, not even through express order. If anybody can correct me if I'm wrong in that, please do. But if any of you actually use Home Publisher and you have some slightly more modern printers, and this includes non-Tandy ones, there is the actual compiled, assembled, should work. There's no errors. Printer drivers that I will be actually adding to the archive. I'll probably be making a new Home Publisher disk with these included that will be put on the archive a little bit later on. So if you guys want to try it out, feel free. Like I said, there's a ton of other stuff on here. There's parts of Springster, there's parts of Sokoban. That's the cartridge one. Springster was a Coco 3 cartridge one. Some of these are actually just executables. There's some stuff that they got from various third parties there, like Sigmon is a debugging tool made by a different company, which I can't remember the name off the top of my head. Hard to type around a mic. Yeah, so there's a Sigmon monitor adapted for OS9 use by David Figge in November of '84. So this is Coco 1.2 era or Deluxe. But this was actually, I think, originally written in 1980 or something. But it's basically a disassembler, breakpoint editor, that kind of thing. So that there's some pretty cool stuff in there. One of note here, I do want to mention, here's Cave Walker and a few others too. One note I wanted to mention is TS Edit. Now, Rick Adams has mentioned that Dale Lear, who wrote TS Edit, patterned it off VI. And then once the Coco 3 came out, we actually had 80 columns. Like the original one was hard-coded to run on graphic screens or the 32 column screen. So you can try to get as much text on the screen as you could. So it ran in basically a P mode 4 screen and had up to 64 by 32 characters, but it's slow because it's all graphic drawn. Rick had patched it for the Coco 3 after the Coco 3 was released, one to be a bit more closer to VI, which is what it was originally based on, but also to handle the 80 column. It looks like Spectral got the original source code from Dale back in, 85, 86 when the Coco 3 stuff, when they got their first prototypes, and they also patched it to run with the 80 column and also be able to run it off a terminal because the original version couldn't do that. It was all hard coded for the Coco. I don't know if this is complete yet. If it is, I'm definitely sending it to Rick because Rick wants to kind of repatch the patches that he did originally. And then also there's some new stuff they want to add in too. And I wouldn't mind doing that myself because it looks like a pretty decent editor. And the ROM boots files. This will be the last before the special presentation, I think. So this is basically a copy of each of the individual modules that they actually have in their original OS9 boot file, but unmerged. And I was talking about how the descriptor did the offsets and stuff here, so I thought I'd show you. So I've just taken a look at the H0 descriptor. So it shows the hardware address at 4EC, which isn't quite right in this case, but I think the H0 basically defaults to being, right off the zero. But 3624 is the start sector number, logical sector number for H1. And if you go to H2, 675C, that is correct. Now, these are base 1. They start at 1 and go up. OS9 internally does base 0, so you got to basically adjust it by 1 sector number. And you can see the number of cylinders, number of sides, and then this really weird sectors and track 0 sectors per track of 276, which is 630, which is the exact number of sectors on a disk basic disk. So that's, I guess it would clue me in that they were handling both, and they can kind of intermingle them between each other if they wanted to. And then you can see the Mega Disk driver up here at the top. That's the actual driver to run the software supporting OS9 hard drives. And then Term 2 Alt and Term 2 was actually an RS-232 pack hooked up to a 80 column terminal. Now, the one that really surprised all of us, I think, when we found it, because this is one of the few directories that was still intact, is another thing that never got released, and it was meant to be an actual commercial game. And where did I put the darn thing?
Hey, Curtis, we're almost out of time. This was a jam-packed 2 hours.
Yep. Did I put it in from? Oh, there it is. Now, any guesses what this could be?
I know. That would be cheating.
Last updated February 1989. This is, I think, after the Coco 3 was already canceled in Australia. Canada was pretty close. And I don't think it lasted too much longer in the States here. But it's River Raid 2, not the original River Raid, but River Raid 2 by Activision. And this one got along where they got a certain amount of it. So there's a little bit of stuff you can actually play and try. And the source code here is intact. There's nothing missing as far as I can tell from how far they got. But I think they literally just dropped it instantly after they got told the Coco was getting canceled. I will mention a few things here. This was meant to run on a ROM pack. It was meant to be a fat binary ROM pack. It's probably going to be a 16K ROM. And it would play on a Coco 1, 2, or 3. The only enhancements on the Coco 3 was that it would be able to run in color and RGB monitor. But basically, it's It was the start of the game that only appeared on the Atari VCS. That's the only other platform that ever got River Raid 2. There's quite a few that got the original River Raid. And this one, actually, when we first found it and we found the binary for it, there's a ROM binary and there's also a disc-friendly version of the binary. Paul and I both tried it and it just crashed. And so on Wednesday night, I started working on it again because I was caught up in work finally again. And I started going through all the different header blocks, like the preambles and stuff where it's loading. And I've noticed there's some pretty odd values in spots, like it's loading code at offset 0. And then I'm reading the comments and it says it's supposed to be loading it at 6,000. And it turns out there's one missing chunk. There's a debug module they have called Bugmon. And it would use this for debugging. It would hook into interrupts and stuff, and you could actually break into a program while it's running. And we don't have that. Or bug out here. That's the one right here. And basically what had happened is that they'd left it for that bug out program to be present, and they would set some of these parameters where these things were supposed to load, but we don't have that. So I went and I changed the preambles manually on the disk image we made of the binary, and then it ran. I had to patch a couple of preambles, and I had to patch one jump address. And then we've actually got a demo we can actually play. So I am going to reboot. Oh, I don't have that loaded. I'll just shut it off. I'm going to switch to composite. Well, actually, no, I can leave an RGB. Yep. You won't hear the sound here, unfortunately, I don't think, but there's not much in it. It's the only sound when you're doing selections. So you see River Raid 2, version X.XX, copyright 1988 by Activision. All race reserved, computer version written by Spectral. And then if you click the joystick, you can move back and forth between RGB or composite. I'm going to do RGB. You can play with keyboard or joystick controls. This does work as far as I know, though I haven't tried the keyboard yet.
You want to go full screen with the emulator there, Curtis?
Oh, yeah, that's actually probably a pretty good idea. Is that better?
Yeah.
Okay, and then you got the option for 1 or 2 players. And that was just going to the demo, but I actually played part of the as far as they got, you can move around and shoot at the beginning, and then it switches to the demo mode halfway through again, where it kind of just you're on rails and you can't do anything. They actually had a high score table built in too. And basically you just increase your thrust off the start and you fly off the aircraft carrier. And then you can change your altitude. You can see the maps moving. Now the map's a bit out of sync with the actual play, but you can actually move. Now I don't know how well the flames animation is going to look here. It's going a bit too fast because they don't have any enemies in here yet. There is some tables of shapes drawn for the enemies, but they don't appear. That's pretty smooth scrolling. I don't know how smooth it is for you guys, but it runs pretty decent clip here, and you can see some of the terrain. And of course, it's not doing any checking to see if you hit the ground or anything yet. And you can shoot. But you can't shoot anything in particular. And then after flying across here, you'll see a little white dot on the map, and then it suddenly changes to the aircraft carrier scene, which just repeats a few times, but I'll let you see that. You can see the dot coming in. And basically it just repeats the aircraft carrier a few times before the demo ends. But Mark didn't know about this. I certainly never heard of it. Apparently, from what Mark said, it doesn't sound like they was involved at all. So I don't know if Spectral talked to Activision directly, offered to do the port. And then when Activision got notified that the Coco 3 was getting canceled, they just dropped it because obviously they weren't going to get paid for it. It wasn't going to show up in stores. But it actually doesn't look bad for a little Coco 1 and 2 game. And, with some fake colors here on the Coco 3. So this was totally unexpected. I had no idea this even existed. Or was even a glint in somebody's eye. And this, we have complete source code. So offer for the Coco community, if anybody wants to finish this game, and there's room for 5 maps. Part of map 1 is defined. There are multiple enemies and stuff in there. Some of those shapes are drawn. Some are just placeholders with zeros and stuff. You could theoretically go in and figure out how the code works so far and actually see if you can finish it. And of course, your restriction is it has to fit in 16K ROM because that's what the Coco 1 and 2 required. Right now, it's sitting at 9.2K, but it has a whole bunch of subroutines that aren't in use yet, but will be by the final game. So if anybody wants to tackle finishing this, then you can base it on the Atari VCS version, which is what Spectral was doing. There's a challenge for you.
But yeah, I was really tickled, Curtis, when you and Paul figured out what was going on here and this drive that I happened to just stumble onto with eBay, and just not knowing what what it was, and then finding out what that we have this piece of history here,
Yeah.
now that we've been able to archive.
Yeah, when we first tried the River Raid, we saw the comments and we go, "Holy crap, what is that?" And then we tried running it; it crashed a lot. That's all it did. So I was just happy that we got source code for like Home Publisher and some parts of Cave Walker and stuff. So if we find any bugs, etc., we might be able to fix them now, or enhance the game or whatever else. And Pan and some of the other stuff is not just games. There's utility stuff too. But getting this to actually work literally about 1 a.m. on Thursday. People were wondering why I wasn't on Game On Challenges because I was sleeping off having to do all this because I had work all day too. So I was kind of napping, and also writing up stuff and getting the demo disc ready to show this off here. But
Yeah,
anyway, Paul, I think you were saying something.
Yeah, I was just gonna say, I mean, as we were working through it that night, I just remember vividly, us, just being in awe at all the little things that we started to find through the reveal, and just think that this was destined for recycling. It was found in an
E-waste.
e-waste recycler, and luckily somebody saved it, and that's just pretty cool.
Thanks, Brian.
Pretty cool piece of Coco history here.
I do plan on. I'm hoping. I haven't figured out everything I'm bringing to Coco Fest yet, but I'm leaning towards bringing this and some other things like this to Coco Fest. I mean, there's not a lot to see when you look at the drive, but still, it's neat to see some history.
Yeah, and being one of the earliest development systems, well, it's the earliest development system for a Coco specifically I've ever seen.
And one of the things that we may have some time to do too, we were talking about this the other night, Curtis, was maybe try to actually build a bootable disk and then be able to actually boot this drive as it would have been, at Spectral Associates.
Yeah. Just like I said, be careful. You can boot it and look at it, but don't save anything on it because I have not updated the bitmaps, and you might corrupt directories and all kinds of stuff if you do. Because that wasn't my goal. My goal was the archaeological recovery onto a clean disk image rather than trying to fix the entire bitmap 10 meg worth of data.
Yep.
So I know we're down to the last couple minutes, and maybe Mark can look at a couple questions in the chat here, but I do have one last thing to show.
Okay, I will stop sharing.
It'll be quick. So do you guys remember how when I looked at the initial image that Brian sent over, and the only text strings that we could pull out of it were the T Harris and T Earls strings?
Yep.
And it occurred in 3 spots. Does anybody have any thoughts on why we could see those strings there?
Oh, why they showed up even when everything was inverted?
Yeah, there's a little bit of an Easter egg.
I'm trying to remember. Their names appeared obviously in the oh yeah, when you do a CLS 100 or something, wasn't it? Or 255 or something higher. There's one that said Microware Corp and
possibly.
I know OS9 also had it if you hit the Control A to repeat the line. It also put the original authors, but I think Ken Kaplan and a few others were in that one.
Yep. So if you pull up the Unraveled Super Extended Basic Unraveled, there's a section in here where it basically states these data are the names of the authors in complemented ASCII to
no way.
T. Harris. So basically what we were seeing was the actual artifacts out of those, the ROM, the compiled, the assembled ROM.
Because these were knotted already in the original and then knotted again, turned it back to normal.
Complet ASCII.
So it came, so it came full circle. So that's, the fact that they did that gave us, the forethought to continue to try to pursue this drive and, not toss it as a completely corrupt drive. So yeah, exactly. So thought that was kind of neat.
Yeah, no, I didn't realize that. So that's cool too. Yeah, just looking at the comments here. I mean, Erico is saying interesting short play field though. That's because they only started working on it, and when the Coco was canceled, I presume that's why they just stopped dead development. There's placeholders for different levels and more map, but they're just filled with 0 bytes. Anyway, we are going to be releasing this stuff as I finish going through it, because there's, like I said, I'm going to try to amalgamate some of the code that's in separate fragments right now, if I can. Try to document a bit more. The first thing I'll be doing probably is the extra printer drivers for Home Publisher, because I've tried assembling those. They're all completely intact. And they are properly dated, so I know which ones were not on the original release disc, so we'll get that out first. But then, yeah, River Raid seems to be complete. The Space Adventure proposal seems to be complete. A few look like they're pretty close to completion, like Home Publisher is pretty close. Others are a bit further away, like Sokobon and Cavewalker. We've got bits and pieces, but not all of it. Also, several of them have mixture of older versions and newer versions. Like Interbank Incident, I found a few source code chunks for the exact same part of the source code that is quite different. So there's versions, and I don't even know which one's the current one. I haven't done a byte compare yet with the actual released version, so we have to kind of clean some of that up as well.
And I started working when we first found the River Raid. I started working on making a repo that would assemble with LWASM, and I'll continue to pursue that. And once I have that finished, I'll go ahead and post that to GitHub. And then anybody that might want to take a look and start playing around and possibly complete the game is free to give it a shot.
Yeah, that's a challenge for the community. I'm not going to tackle that one.
Well, thank you, gentlemen. This has been very interesting. Very, very interesting.
Yep. Thank you, everybody, for watching.
Yep.
Yeah, thanks for having us.
I hope all the hype I put into it last week wasn't overblown.
No, it wasn't. Archaeological find? Unreleased game? No, very worth it. Okay, moving on. Up next, we have William Athing and Henry Gernhardt, who are going to be doing a FujiNet presentation for the next hour. And I need to close down the stream and reset the titles and restart it up. So remember that it's going to disappear in your web browser and you need to go refresh your page, except Twitch, which just automatically fixes it. So all you YouTube people, refresh the Coco Nation page or the Glenside page and you'll see the new link. So thank you much, gentlemen, for being on, and please say goodbye.